Hey guys, welcome to another video, and in this video we'll be talking about center of pressure and how it is related to the angle of attack, and finally we'll also be talking about the stalling angle, right? So we already know about the four forces of flight, right? We have continuously spoken about it, though we have not covered all of it yet, but we know what are the four forces of flight. It is lift, weight, thrust and drag, right? So I've drawn a few diagrams which you don't have to worry about it yet. I'll explain everything, right? So this is a diagram. Just look at this diagram for now where my finger is. So there is four forces of flight, which is lift, weight, thrust, which forces the aircraft forwards, and drag, which basically drags the aircraft behind, or it is the force that is against the thrust, or basically it can be called as friction, right? So these are the four forces of flight. Now when it comes to the center of pressure, now what can like in basic definition, center of pressure can be defined as the point on the aerofoil through which all these forces are acting. So now if you see that there is lift, weight, thrust and drag, there's all actually if you look at it, it's all 90 degrees or 180 degrees basically to each other. There's a 90 degree that is forming here. It is all perpendicular to each other. So in this particular case, this particular point that you see where all these forces are acting is your center of pressure, right? Now I want you to look at this diagram, right? This diagram. So this is like a pressure distribution diagram. So if you look at it, there's a plus sign here, there's a negative sign here, but you can see that there is a whole pressure distribution area out here. There is a pressure distribution area out here. So what it's basically saying is, just as we said, as air moves inward, there's a high pressure created below and low pressure created above, but finally what happens is that the aerofoil is pushed upwards, right? That is our basic requirement, that we need lift to fly. So this diagram is basically summarized as this. So it is simple. It is the total reaction, TR. I know it is looking inverted because I'm using the front camera of my phone, but this is TR, or total reaction. So this is the aerofoil, and if you look at it, the total reaction that we want is upwards in case of an aerofoil. So basically this can be summarized as this diagram, in which the pressure differential, basically high pressure below, low pressure above, pushes the aircraft upwards, and the sum total of all this has to be an upward push, right? And that is your total reaction, right? And that is going through this point called as a center of pressure, right? I want to draw a few more diagrams. This board was full, that's why I couldn't. Now what is the angle of attack? It's again, I remind you, is the angle between the chord and the relative airflow. Now let's have a look about what happens as the angle of attack increases, right? So we will take four situations into account, right? And before we talk about it, I am also reading through a few stuff for you so that you can understand. So it says, at normal cruising airspeeds with a small positive angle of attack, the CP is positioned on the chord line near the center of the aerofoil. So basically, when the aircraft is at, let's say, in case of a civil airliner, it is cruising at around 700 kilometers per hour, but let's leave all that apart. It says that when it is at cruising airspeed, it is, and with a small positive angle of attack, let's in this case say that it's plus 2 degrees, right? Let's say it has a 2 degree angle of attack. In that particular case, it's saying that the center of pressure is positioned on the chord line. So the center of pressure will always be on the chord line. It will always be located on the chord line, right? So I will put instead of actually drawing and showing it to you, I will actually try to paste a picture onto it so that you can understand it much better, right? So in the first particular diagram that you can see, it shows that the angle of attack is 2 degrees. You can see a small picture on the right. It shows that it is 2 degrees, and what it says is that I would like to read it to you so that I can explain it after that. With increasing angle of attack, the center of pressure moves forward towards the leading edge. So if we remember what is the leading edge, so I actually drew these diagrams. So let's say this is an angle, a 2 degree angle of attack, right? So what basically happens is that in this particular case, you can see that in this diagram, the first aerofoil, you can see that the center of pressure, where you can see lift and the total reaction and all coming out, it's in the center of the aerofoil. It's on the chord line, of course, but it's in the center. Now in the second diagram, you can see that the angle of attack has increased to +8 degrees, right? When it comes to +8 degrees, what has happened? You can see that the lift is increased, the drag has decreased a bit, but the total reaction has increased, right? But you can also appreciate that the center of pressure has moved forward towards the leading edge. Now again, in the third case, when the angle of attack is 15 degrees, you can again see that the lift has increased, drag has also increased a bit if you look at it in this particular case, and we'll be talking a lot about it when we come to the section of drag. But you can see that the overall total reaction which we want, which is the lift, has increased, right? So basically our aim is to get more lift compared to drag, and that we are achieving in this particular case as at 15 degrees. And you can also see that the center of pressure has moved forward, right? But now in the last diagram, what are we seeing? At 20 degrees angle of attack, what has happened? The center of pressure has moved backwards, lift has decreased, the total reaction is much more diagonal. So this is not what we want. We want an upward force, right? We want upward, we want lift, and drag has increased. Now what does this mean? Now what happens is, as the angle of attack increases, of course lift increases, but there is a certain point, there is a certain angle of attack at which there is no more lift and there is a lot of drag, the air gets turbulent, and this is called as a stalling angle. In the fourth diagram, you can see a classic example of an aerofoil approaching its stalling angle, or in this particular case is at its stalling angle. Now stalling angle is the angle basically at which the aircraft is producing more drag as compared to lift, right? So in this particular case, what will happen? The aircraft will start descending and the aircraft, there will be a lot of vibrations and all these cases. So angle of attack is good, but anything good in too much is bad. So that is what it is. So too much of angle of attack will lead to a stall, right? So that is it. And I hope you understood something. If not, feel free to send me your questions. We'll be happy to answer. Happy landing, guys. Cheers.